This meeting is being recorded.
Hello, good afternoon, everybody. Welcome to this workshop, Boosting Research Results Through Standardization. Thank you for being with us today in this afternoon of July, quite warming actually in Italy. We hope this workshop will be a nice occasion for you all to see how innovation can have a boost through standardization. And we will let you have some examples from the projects belonging to the ForeSee Cluster. ForeSee Cluster is a cluster of now 11 projects, most of all linked to predictive maintenance. And 6 of these projects will showcase today how standardization can boost innovation through their direct experience. This is all linked to the new European strategy on standardization. But first of all, before starting, it would be really nice to have your view about how innovation may boost standardization. So we have prepared a very fast poll, just asking you a question about how standardization, how, in your opinion, innovation can have a boost from standardization. Here there is a link. I would kindly ask you to click. We will in a while share it with you in the chat. And there is also a QR code here on the screen. You can just use it to share to access to this poll through your phone. Adriano, please, if you can share the link in the chat so everybody can join. I will show you in a while how your answers are coming.
Yes, give me just a.
Thank you. So the idea is like to have, first of all, your impression, your feeling really in a very brainstorming way on how do you expect that standardization can support innovation. Just basically clicking on the link that Adriano is gonna share with you in the chat, you can answer to this poll just really in a brainstorming way. So don't think too much, just think at your experience with standards, also in your day-by-day life, and how this can be linked to innovation and in which way they can benefit, the innovation can benefit from this standardization. Now we will collect all your answers, and this will be a very good starting point for our further presentations. So first of all, by project manager from SEN to explain which are the underpinnings highlighting the link between innovation and standardization, and then we will see how these underpinnings are actually covered by European projects from the ForeSee Cluster experience. You can see the link in the chat. Just give you some few minutes to answer to the question and just thinking a little bit about it. And then in the middle, there are these waves, so that hope will help you to focus on your answers. I hope you can see the link. If you have any trouble, please let us know. Really, don't worry, any idea, any brainstorming, it would be much more than appreciated. Okay, perfect. So let's see what's happening. I'm gonna show you the results. Well, it seems that many of you have answered that innovation can benefit actually from standardization through the transferring of research and innovation results to the market, facilitating the acceptance of the innovation by the market and accessing to the market. So the word market, it's something that it has been repeated many times. And this is really, really nice because it's perfectly in line with the idea of today's workshop. And I will give the floor to Philip, who will briefly show you what's the SEN view about this link between innovation and standardization, and why actually the market can benefit from standardization. Thank you, Philip. The floor is yours.
Thank you, Christina. Let me just share my screen. Is that visible to everyone? Yeah.
Yeah, perfect. Thank you.
Okay, great. Yes, well then, yeah, first of all, thank you for having me. My name is Philip Moha. I'm a project manager in the Market Perspectives and Innovation Department at SEN and Senelec. And as Christina has already said, I'll just be briefly talking today about what standards can do for researchers and how we can integrate standardization into research projects. So I have a lot of ground to cover, so I'll just get right into it. A lot of our activities based around the SEN and Senelec Strategy 2030, and currently the innovation activities promoted by the strategy are threefold. So the first step is the integration of standardization and research. We want to gain a better understanding of researchers' needs and also highlighting their work in standardization. We are constantly looking for new topics for standardization and how to identify these. We are in the process of developing a foresight mechanism to increase standardization in new technology areas. And we are also looking to raise awareness and build system capacity. We are aware that there is a lack of visibility of standardization in research, which is something we'd like to change. And we're also constantly establishing new partnerships with national and/or European institutions. As I mentioned, all of this is in line with the Strategy 2030, which encourages the use of SEN and Senelec deliverables as tools to enhance the impact of R&I projects and to develop an inclusive European standardization system where research actors are encouraged to bring forward their ideas for the development of new standards. Now, in tandem with this, the European Commission launched in February this year a new EU strategy on standardization, which intends to usher in a new era for standardization in Europe and increase the influence of the European market on the global economy through standards and standardizations. A key point here for researchers is the HS booster, or the Horizon Standardization Booster, which was launched via a Horizon Europe call. Researchers and research projects have the opportunity to submit both past and ongoing Horizon 2020 and Horizon Europe projects. And then the booster can provide standardization expert services to help these projects both increase and valorize their project results. I can provide a link to this in the chat later on after my presentation. And another key point of the standardization strategy is the Code of Practice on standardization for researchers that was launched earlier in May. This is a draft proposal discussing the best practices on increasing the link between standardization and researchers at the policy, project, and academic level, and how standardization can support these. As SEN and Senelec, together with our members, we did submit a response to this draft, and we want to bring this draft closer to the European standardization system, and this code will hopefully be published later this year. Now, the key question is, of course, what is in it for researchers? How can standardization support researchers? So the first way we see is that standards can be a way to increase both impact and access to the market. Standards build trust and they make technology more acceptable to the market. Secondly, we believe that joining the standardization community provides researchers with a network of relevant industry stakeholders that they can liaise with, but also provides a network with other researchers in the same field. And thirdly, research and innovation input into standards is acknowledged via reference of scientific publications, creating an avenue of recognition for one's research and one's research results. Now, building onto this, we also see that standards can valorize research results through what we call the standardization flow from research to standards. Standards bring innovation to the market by making the results transparent and ensuring quality, but they also build trust in consumers by guaranteeing their safety and quality to consumers. Standards also support the codification of technology requirements, informing manufacturers and consumers on what they can expect from these new technologies. And of course, standards ensure interoperability of technologies and materials. We are constantly looking for new ways to make our system more flexible and agile and approachable for researchers, as we are aware that oftentimes standardization is observed as unnecessary red tape or as a hindrance by researchers, which is obviously not the case and something we want to make more attractive for researchers. Now, if you want to include standardization in your research and innovation activities, there are various ways you can go about this. Usually the first step we recommend is screening existing standards to get an idea of the current status quo on industrial and societal practices. We also highly recommend getting involved with the standardization community, either by joining TCs via an NSB or establishing a project liaison. I'll have more on this in the following slides. You can also translate your research activities into ongoing work and propose new standards or modify existing standards. Of course, these are lengthy processes, which is why we have also developed the fast track approach to standardization via our Senelec workshop agreements. I have a slide with more information on that as well. As I had previously mentioned, one of the ways to include standardization in your R&I activities is to join a technical committee as an expert via nomination from your national member, or also you can establish what we call a project liaison mechanism. These mechanisms are possible when there is already an existing technical committee in this field of technology you'd like to advance into, and your project can then directly provide input into the standardization processes through this project liaison mechanism. The mechanism also allows the project consortium to exchange information directly through the running of the project, throughout the running of the project with the standardization community, and you can contribute to the ongoing standardization work that's going on in this technical committee. However, as opposed to being an expert that is nominated by a member, there are no voting rights when you are just a project liaison. We also have the fast track to standardization. As I had mentioned, this is the Sen and Senelec workshop agreement, or CWA. It's what we call a pre-standardization deliverable, and the purpose of these CWAs is that they're fast and flexible. So usually these can be developed in 6 to 12 months, and they're designed to meet immediate needs of a research project, while also still keeping the door open to the development of a European standard future. These CWAs usually have a lifetime of about 3 years, but they can always be extended or revised or even withdrawn if a European standard is developed. And it is also worth noting that these CWAs aren't developed by technical committees, but instead by specific temporary adopted groups. We also have other pre-standardization deliverables on offer, such as a technical specification or technical report. And you can learn more about all of these on our website, specifically with Guide 29 on CWAs. As I mentioned earlier, we also have some activities going on to raise awareness and build system capacity. The first of these is the Putting Science into Standards workshop, which is an annual workshop in cooperation with the Joint Research Center of the European Commission. These workshops generally explore new technology areas that have not yet been covered by standardization, with the aim of bringing standardization into this area of technology. In the past, this has been topics such as hydrogen technologies, quantum technologies, or organ on a chip. And most of the time, these workshops lead to the development of a focus group where researchers, innovators, and standardizers can then work together, share ideas, and establish this link. Currently, they are only annual, but as they have been well received in the past and also been mentioned in the European Standardization Strategy, we do plan to create more of these workshops, potentially on a smaller scale, to expand the opportunities to link between standards and research. The other activity we have going on are the Standards and Innovation Awards, which is an award scheme we've developed to celebrate R&I contributions to standardization. These are awarded every year in 4 different categories for individual researchers, research projects, young researchers, and technical body officers. You can see all of the previous year's winners and the nominations for this year on our website, including details on their projects and how they involved standardization in their projects. I do highly recommend checking that out. There's a lot of interesting topics and opportunities to observe there. Finally, if you'd like to learn more, we have some websites that we've developed. There is the Standards Plus Innovation website, which shares success stories of standardization in research and innovation projects, but also has upcoming events and news. And we have the Standards Plus e-learning website, which is dedicated to explaining the standardization system to researchers and is complementary to today's presentation. If you'd like to stay in touch with us or learn more, you can also join our Standards Plus Innovation community on LinkedIn. You can contact our research help desk at any time and we'll get in touch with the relevant support you need. Or you can also contact your national standardization body, who will also be able to provide support. That's all I had for today. Thank you for your attention, and I'll pass the floor back to Christina. Thank you.
Thank you very much, Philip. A really super interesting presentation. I have seen that there are also already some questions and considerations in the chat. And I have seen that also Nicholas Ferguson, who is the Standardization Booster Coordinator, has joined this webinar, and he's also eager to support you for eventual questions at the end of this webinar. So thank you very much. Now you have seen this very broad overview of which can be the different activities that standardization can do to boost innovation. Now we will give the word and this stage to the different types of European projects we are going to showcase today, to let you see and touch with your hands how what Philip has described today can be actually put in place in European project. The first one is Yves Kerreron. He is president of ISADEUS, and he is going to show you the project Uptime Unified Predictive Maintenance System. Please, Yves, the stage is yours. Thank you.
Thank you. Thank you, Christina. Yes, I am Yves Kerreron. ISADEUS is a company I created a couple of years ago, maybe 9 years ago. It means innovation, standardization, and digital engineering using semantics. So, and I was actually in charge of the standardization aspect of the Uptime project, and I am also involved in ISO TC, especially 184 SC4 for industrial data, and also in some liaison committees. So I will give you an overview of the Uptime project. how we carried out standardization activity as the first lessons we learned from this very interesting experience, and some thoughts on future developments, not only from uptime, but also from my experience in energy industry and in engineering. And here you have the picture. You have 11 partners from different kind, consulting companies, technology providers, and also industrial companies for the use case in the white goods industry, in the steel industry, and in the production of jigs for the air and space industry. So here is very briefly the uptime platform. The innovation consists of the composition of different components, which are also each innovative. And first, the innovation also is to make a versatile whole you can plug in different industrial context. And so you have here the list of the different components, and from the data acquisition to the decisions proposed to the team of maintenance. And also we have some advanced visualization tool, and also advanced machine learning techniques to analyze batch data, and also we have a component for analysis of failure mode and criticality. So the needs for standards is for the interoperability of the various components, and also for the integration with the legacy information systems. And of course, after to have an extent of the market. Here are the free use case, and so with the typical impacts searched by the different companies. And so I will go through quickly. Actually, how we should very briefly present this uptime platform. First, I think it's important to put the users at the centers, and I would say the social aspect. There is teams to maintain an industrial asset, and the uptime solution will improve their way of working, their efficiency in the work of the team, to maintain a functional unit or production unit. So after, yes, we have the best of the breed technology. You know that researchers are always searching for the last and how to say up-to-date technology, and that is very, very important. As we say, it is open, modular, and it can evaluate according different needs at a low cost. It's not a big solution, but it is a progressive solution. It combines models. We have seen the FMECA models, but with AI analytics, artificial intelligence analytics, use advanced technologies for visualization, and implements a kind of digital twin, which is extensible with other technology. So first, we recommend to use existing standards, but we have to make a difference between business or technological standards. I mean, business is, for instance, standards on how to carry out technical activities and maintenance, and more technological ones are more concerning the formats of data, for instance, are more the other point is to adapt or to produce new ones when there is gap to achieve this goal of the uptime platform. Here is some general thoughts about the context of industry. Industry is always looking for competitiveness. Industry needs innovation, but this innovation has to be based on existing standards, as I said, and also to produce and to propose or to participate to TC in liaison, for instance, as Philippe said, to produce new standards. And what is particular is that it is in a new technological environment, and it's quite difficult to assess the impact and to find a thread in all this landscape of standards, because there is so many standards, and so we need to find some clear way to address this issue, this challenge. So. First, as I said before, most of the components are the best of the breed, and so are open source, most of them. And I would say that as such, they play a role in the standardization process in industry, because open source components can be reused, modified, enriched, and so on, and they are public. And compared to login solution. So there is also the computation of legacy data. That's not so easy to first to have data of quality and so on, to make analytics. And we manage structure and non-structured data, data from the flows from IoT sensors. We make also edge computing, proactive computing. That is the fundamentals of the innovation of uptime. Concerning standardization, we make a list of the existing standards in the domain. We think it could be important, and we make also a questionnaire survey to see how the actors know these standards. Actually, the result is that there is a very poor knowledge of existing standards. There is a very good knowledge on advanced solutions and so on. We had many IT people in the consortium, not so many people familiar with maintenance, for instance. And I think it's important to have these people work together, business people, the maintenance people, with IT people. So we focus on the functional standard. We have a functional architecture following a standard. And also on the standards to exchange data between the components. These are more low-level technical standards. We considered also the Mimosa schema for the exchange of data with legacy systems. And we made also efforts, because it was identified as a priority, on a common vocabulary by carefully analyzing the definitions of maintenance terms in the maintenance standards and vocabulary, maintenance vocabulary. So sorry. Yes, I come back. Sorry, I put the slide. It was the right place. Concerning the industry competitiveness, you can have an idea about the increase of the overall equipment efficiency, the reduction of the maintenance cost, and the mean time between failure and so on. and the mid-time to repair. To follow this complex landscape of standards, we have introduced a methodology used in aerospace industry, which is the radar chart, and it is quite complex. It is a very synoptic view, but it could be long to explain. But you can see there is adopted standards you follow, or the candidate standards, and there is four quarters: adopt existing standard, monitor external development, or participate in external development, or make development in an ecosystem. And we can see the adopted standard on the left top quarter at the center of the radar chart. This is a picture which change with the time, of course. It's not. So the main lessons learned and the possible improvement is the way forward. So some standards have been successfully implemented. The ISO 13374, the uptime solutions perfectly follow the different functions described in this standard. The IEC 6812, which is the MECA, and MQP, MQTT have been implemented with success. So it would have been nice to have VECA modules ready for use. Be careful to make them adaptable to various contexts, because the environment, of course, has great importance, and the reliability of components and for an equipment, and maybe the future specification of the asset and resistance shell could address this in the future. And industry is very interested, but maybe is a little bit waiting. It is more mature. So I had the question from the beginning of the project, if there was a standard to break down an asset. And I think it's a very, very good question. It's very, very important. And actually, since that time, I made research and application of the ISO IEC 81346 series, which is a perfect standard to break down industrial assets according to different aspects: functional, product, location, and also to designate the different objects of an asset, which is the first step to, after maybe through a link data technology, for instance, makes a link with reference data libraries, common data dictionary, standards, smart standards, I mean electronic standards, and so on. So the difficulties, we have difficulties to address the semantics, although we make efforts on vocabulary. For instance, there was not such enthusiasm for ontologies in the team. We discussed that many times. And okay, so yes, the standard we analyzed was 13306 about maintenance vocabulary, 1707 about maintenance processes and indicators.
Eva.
Okay, I will. And so thoughts about future development, I think it's very important to focus on relationships, system mindset, and I think there is not so many relationships actually, but the most important one are the all-part relationships, the class-subclass relationships, and the non-hierarchical relationships. The smart standard of course, there is a link to the ISO site, and ISO NIC are making efforts on this. And a model-based system engineering mindset, that means actually a common methodology, a common approach, systematic approach, but taking into account that there is a diversity of systems, a diversity of standards to be applied in different contexts. So we have not one unique system and not unique standards, of course. And efforts, I think, I don't know about science and technology, but I think
Eva.
Yes.
I'm sorry.
Yeah.
Can I ask you just to thank you very much, to briefly sum up the conclusions, so we can also give the floor to the other panelists.
Yes, and I think it's important to have a scientific approach in this domain. And for instance, there is work interesting in NIST, National Institute of Standards and Technology in Washington, who is making very interesting efforts to address the complexity of modeling according many dimensions using advanced mathematics. Okay, that's my conclusion.
Perfect. Thank you very much. Sorry, if just because there are, we have like 6 panelists, so just to give also them the time to present their projects. Really much interesting, and I have seen many hints answering to the brainstorming of the first question from all the participants to the workshop, especially your point on the how standards can help the interoperability between systems on the market. So now we will continue with Iphigenia. She's a project manager from TNO, and she's going to showcase the MAS4I project, a multi-agent system for pervasive artificial intelligence for assisting humans in modular production environments. Please, Iphigenia, the stage is yours. Thank you.
Thank you very much, Christina. Give me a second to share my screen. I'm not very familiar with Zoom because we usually use Microsoft Teams. So where can I share my screen from?
You should find
okay, it's here.
Perfect. I think Iphigenia is having some problems with internet connection. So I would say, just to give her some time to rejoin the webinar, I will give the floor to Evangelos, who is going to present the Qual project, and then we will go back to Iphigenia when she is able to restore our connection. Thank you, Evangelos.
So Christina, just to make sure I have 10 minutes for this, right?
Yeah, perfect. Okay. Thank you.
Let me set my screen and set my timer. You should be able to see it now. And full screen. Timer on. So, yep. Thank you, Christina. Yeah, my name is Evangelos, or Evan in short. I'm an assistant professor of human augmentation in the design engineering faculty of TU Delft in the Netherlands. And today I'm also as a representative of the Qual consortium about cognitive assisted agile manufacturing for a labor force supported by trustworthy artificial intelligence. That's a very big acronym. In short, I'm responsible for the work package 3 of this project, European Horizon 2020 project, which is basically delivering the cognitive advisor for manufacturing. Just before we dive in, I will give you a little bit of a background, and I hope most of you are familiar with these terms. I guess most of you know what Alexa is, or Cortana, or Siri, all these cognitive, all these digital assistants we have that are becoming more prevalent, and they have some specific characteristics. The most important one that differentiates them from other systems is that they interact with the users via natural language. You can talk to them, basically. You don't need to click buttons, ideally speaking. They support or take over time-consuming tasks, such as finding you the best itinerary to go to the beach in the hot day without you needing to kind of touch any device, and they're able to deliver these instructions to you in a verbal way. And they typically have some anthropomorphism ascribed to them, which means that people kind of treat them as if they are humans in a way, because they have this natural way of interacting with the users. And they typically know how to do things that people think they are intelligent, like finding you a route to the beach, as I mentioned earlier. And what's important about them from a software architecture perspective is that they have the interface, as you can see here. The orange thing is the icon here is for the user, and they talk to the purple one represents the digital assistant. And what it does basically transcribes all the speech that is broadcasted to it to text. Then it does some NLP and natural language processing in the background. It has some dialogue management, and then it's depending on what we call the amorphous backend. So it's like could be the cloud, could be a variety of systems, could be databases, could be any sort of APIs, application programming interfaces. In order to that's where they pull their knowledge and their intelligence from. Then they have a dialogue management component, and then what they do basically, they come up with a solution to a problem or a recommendation, and they're able to verbalize the text back to speech, and then that's how they give the impression of being intelligent. Just a quick intro to them. So on the other hand, we have a domain, a very interesting domain, which is the factory of today, which can be characterized by long distances, narrow spaces. It's very noisy. Manual labor is actually done there. Another characteristic is that we have declining workforce. These particularly pictures are taken from Qual partners, commercial industrial partners, and their premises in Italy and in the Netherlands. And many of them report that they have difficulty in maintaining their workforce or attaining new workforce. And other tasks that happen and take place in this domain is automating tasks, typically with using smart machines, robots for robots. And there's a lot of sensors and IoT and APIs in all of these modern factories of today. So we put two things together, and what we have is the Qual Cognitive Advisor with two main use cases. One is the augmented analytics use case, where the Cognitive Advisor collects and analyzes data from the shop floor based on this backend I just presented to you. And the other one is on-the-job training, which is basically we assign the Cognitive Advisor, the Qual Cognitive Advisor, this chatbot basically, on steroids, we like to call it, to train the novice users and the novice operators that they work on the shop floor next to the machines, and to kind of replace a little bit the presence of a more expert person while being next to them. And at the same time, it can adapt the recommendation it gives to the profile of the particular operator, being more novice or less expert or more expert. And ultimately, what we're trying to do in this project is to use this system, because it's about a full system, to unveil and discover best practices that we want to convince the operators to actually use. So the benefits of using a chatbot, basically, to put it simply, in the factory, is that it gives you central access to a plethora of information that is available in every factory, can be adapted to the user. You can delegate tasks to it. It's eyes-free. You can use basically the voice interaction and your ears to hear to it. It could be instructive and collaborative. It doesn't demand things to be done. It just does them with the operator in tandem. It's hands-free. Most of the times, also in some of the pictures I will show you, it's not very hands-free at the moment. It could be ubiquitous. It's everywhere across the shop floor. It's multimodal. You can use text or speech to interact with it. It's always on. It's always responsive. It's context aware. It knows where you are on the shop floor if you're an operator. And the most important of all, personally for me, is that it's intuitive. So you don't need to learn anything to interact with it, because you use your natural language. That's the main selling point of this technology. Then diving deeper in how the first use case about augmented analytics works is that we have the context being inputted into the dialogue. We have dialogue management. We have a graph database in the back end, and together with a plethora of data coming from machine vision, machine APIs, or historical data from other databases, it can predict and actually propose a recommendation to the user that's coming backwards in the pipeline and verbalized as a potential recommendation in actual words to the user while at the task. And quickly, the second use case we have here is that, as I said, it supports the on-the-job training. So we can actually, a novice operator can ask for instructions. How do I turn on this machine? Or how do I refill this machine? Or what do I do to produce X product? Which are the, the specific adjustments I have to put into the machine. The next level is you can share knowledge with the assistant. The moment that the assistant detects that you're doing something good, can actually ask the operator to input exactly to explain what they did, because apparently, I don't know, the production went up by 3% or something. And you can also provide learning content as what we call nuggets. So it is also a platform for showcasing multimedia, video or pictures or sounds that can help people learn, help operators learn and be more productive while they have no support on the shop floor, basically, from some more experts than they are. The main considerations we're designing the cognitive advisor can be summarized by 3 pillars: settings, ethics, and privacy. Usability is also concerned, but we don't focus so much at the moment here. When we talk about settings, we talk about very noisy and highly demanding settings that they are, such as in the factory. When we have high noise, it's not the best. Basically, you might say, okay, it's not the best to talk to the chatbot. Yes, but you can have special headphones that filter the noise, and the microphone can also filter the noise from the machines. So you don't need to hold the tablet in front of you. You can put it somewhere else, or you can have a mobile phone, or you can have some remote, some mobile device to actually interact with chatbot through voice only. The other consideration is about the ethics, and that's one of the most important ones here, because this type of smart systems could create an imbalance between employer and employee. Typically could be translated or interpreted in a loss of autonomy or bias in how you train the data. So, for example, we have more male operators than we have female operators, and that could make this technology somehow biased towards male operators, because that's the main sample that we train our models on. And it could lead to specific ethical problems, such as following uncritically recommendations from the advisor, suggesting procedures that could harm the user, perhaps, or damaging the equipment, or in the end creates the knowledge gap of who owns the knowledge. Is it actually the company? Is it the operators? Is it both? And who manages this knowledge at the very end? And the third aspect is the privacy of the operator. As I mentioned before, we use all these machine vision cameras to streamline the dialectic interaction with the advisor, to make it faster, to make it better, to improve user experience, to increase user adoption. But then all of this create huge privacy issues that could be problematic in the future or at the moment as we go forward in deploying these technologies. For example, you can actually reveal users' names or co-workers' names. Employers could see and track operators on the shop floor. These are kind of sensitive issues to tackle. And for this, we are planning a long series of testing. We want to test in different areas, preferably in the real world, and test the different layers we have in our architecture, such as the Microsoft and Raza open source applications mainly that support the cognitive stack, the architecture stack I just showed you. What is the focus? We want to test usability, we want to test cognitive workload, and also trustworthiness, like how much the advice is projected by the chatbot is actually trustworthy. And finally, test with actual users. However, there is also the problem again with not having equal sample representation for the two sexes or genders. And at the moment, we are on this stage of how we're going to move forward. We took the decision to first test in our own premises, in our lab in the university, with simulating the shop floor, how a shop floor looks like in a specific lab, and even simulating the machine user interfaces on a big touchscreen. And we also have realistic tasks that the operators don't normally do across the production line in a specific factory. And we recruit maintenance experts from our premises, technicians, lab assistants as operators and as our participants to test this in the lab, and why for forming a baseline in ideal conditions, so we have something to compare against. That's perhaps a link to standardization, or maybe perhaps a remote one, but that's how I see it at the moment. And with it, I will conclude. This is our contact details. If you want to get in touch with us in the project, take a look at the project if you like. I think it's very interesting. And that's our copyrights. And with it, I'll conclude, I think. Yeah, thank you, Christina.
Thank you, Evangelos. Thank you also to sticking the 10 minutes time frame. Was really an interesting presentation. Qual is one of the showcased projects of today which has not specific activities regarding standardization. The reason why we have already chosen to showcase this project is also to see and discuss in the last part of this workshop how also these projects which have not foreseen from the very beginning some standardization activities can eventually include also standardization activities among their output or not, if maybe standards are not the right choice for them. So it's a point for discussion. Now Iphigenia is back. She had some issues with her internet connection. Now I think everything is fine. So please, Iphigenia, share your screen. Thank you. I'm sorry, you're muted.
Okay, I'm back. Okay, let me share my screen again, and I hope no more technical problems. There we are. Okay, so hi everyone. Thank you very much for having me here today. My name is Fiona Thanasiadou, and I'm a project manager at TNO. As Christina said before, today we present you the Mass4AI project, which is about multi-agent systems for AI and for assisting humans in modular production environments. The agenda for today includes a short project outline, the motivation and vision for the project, our standardization efforts, and the European partnerships that we have built so far. So starting with the project, it's an ICT 38 project. It started in 2020 and it will end in 2023. The budget is around 6 million, and we have 17 partners all over Europe, including RTOs such as TNO, DFKI, AMS, and also we have many use cases in different fields, and we have technology providers from different companies and areas around Europe. So the Mass4AI project is motivated by the recent changes in the European manufacturing industry. This industry is more and more confronted with increasing international competition. First, there is a growing demand for high quality, customer-specific product design and manufacturing in very small sizes. And this leads, of course, to growing complexity of the production facilities. And we can see that there is need for agility and responsiveness of this kind of these new production processes. The artificial intelligence for manufacturing could be a very good solution to that, to tackle these problems. But however, the market entrance for the AI products is often blocked because of first, missing interoperability between different systems. Second, the fact that commercial AI algorithms are restricted sometimes to specific frameworks. And yeah, also because of the missing support for diverse AI methods. Therefore, what we believe in Mass4AI project is that there is a need for a full spectrum vendor-independent AI technology, which can contribute to hyper-agility of the European factories. However, the existing AI technology manufacturing, sorry, I was confused. Yeah, there is a gap, and the existing AI technologies in manufacturing throughout Europe are in general good in demonstrating the feasibility of solving specific decision-making and optimization problems. However, they are quite weak at transferring these abilities, the technical abilities, into more general improvements of production facilities and specific business cases. Mass4AI therefore utilizes these capabilities of existing IoT and AI technologies in a more efficient way. So the focus of Mas4AI is actually, while using these IoT and AI technologies, to have agility and safety of the technical solutions within the production processes, to integrate humans into the decision making and the workflows, and to make sure that there is interoperability of AI solutions and new business models and market opportunities. So the vision of the project is quite clear for us. So the traditional hierarchical enterprise IT does not work that well anymore. There's a trend to move towards cloud and distributed systems. Moreover, we need a lot of functionalities like planning, HMI systems, quality inspections, etc., which are rather independent. That's why a distributed multi-agent system can be a solution and is proposed by the project. So due to the complex requirements in the area of production, we provide a multi-agent AI system, which is able to integrate diverse AI technologies and combination of these. The AI components can be distributed on different hierarchy layers within a modular production process, from smart module layer to the smart factories and up to production whole smart production networks. And also in order to have unified, reusable and scalable solutions, the AI components are embedded in intelligent agents, which can be combined in a flexible and agile way. Then, considering the challenge of autonomous modular production, the Mas4AI project uses semantic self-description capabilities of technical modules, as well as the optimization of configurations and processes. It also uses intelligent human assistance with the awareness of human capabilities. And lastly, it uses highly reactive and safe solutions for complex production processes. What we want is to implement, benchmark, and demonstrate the technology in industrial pilot cases under real manufacturing conditions and across different market sectors. What is also very important for us is that we need to establish the connection to existing platforms and European networks, and this will allow us to integrate and deploy AI components freely and to use the available resources. Lastly, the project aims at providing standardized data models and deployment architecture in the form of AAS submodels and a multi-agent system architecture based on Janus framework. So we truly believe that standardization can be the perfect tool to actually create impact through our project and to have a lasting impact. So when we finish the project, we can continue from that, and it's not wasted all the effort that we did. And we really put a lot of effort in standardization. The main objectives for that is, as we also discussed before in this workshop, is to facilitate the acceptance and utilization by the market of the solutions that will be developed, to ensure that these solutions are compatible and interoperable with what there is already in the market, and to use the standardization system as a fast and very effective dissemination tool. The way to achieve that is very simple. We started by identifying and analyzing what there is already on the market, what are the related standards. We have started collaborating with the relevant standardization committees and also other associations in this area. And we aim to contribute to the ongoing and future standardization developments using the results of the Mas4AI project. So the ongoing and plan for the near future activities are, as said, to continue establishing connections. So far, Mas4AI has established connections with BDVA and IDTA. And we aim to contribute to AAS submodel standardization in collaboration with the DimoFact project and the Industrial Digital Twin Association. We also aim to contribute to the development of 7392 standard as a representative of BDVA. And also for us, it's important that we aim to use that to strengthen our standardization efforts. That TNO recently became member of the Open Industry 4.0 Alliance. We have been connected and we really try to grow with many associations around Europe. And we try to see where we can connect so we can grow together in this area. Probably you know most of them. Yes, we have some recent additions, as said, and I would be very happy to hear any suggestions for further collaborations also from your side. That was all from my side. Thank you very much, and I'm very open to any questions or ideas.
Thank you, Evgenia. Really much interesting. Again, we have seen this idea of interoperability as one of the main point which standardization seems to bring to innovation, to research and innovation projects, to bring to the market the innovation which is not yet the state of the art. So thank you very much for these hints.
Thank you.
The next panelist is Adriano. Adriano is a project manager from UNI, so the Italian standardization body, and he's going to showcase Reclaim project, remanufacturing and refurbishment of large industrial equipment. Adriano, please, thank you.
Yes, thank you, Christina, for introducing myself. We are colleagues, we're working together. And today I'm going to show you, do you see the right screen? Yes, in the right way, the presentation.
We see like the presentation mode.
Okay,
Try
is it fine now?
Just you should click on the, try again, please.
Just give me a second. Okay, I will do like this because it goes on the other screen and I don't know why. Okay, did you see
the presentation? Okay, just open the PowerPoint.
Okay, is it fine now?
Yes, I see PowerPoint.
Okay,
okay, perfect.
Okay, sorry.
Cool, thank you, Adriano.
So as I said just a second ago, I will introduce you the Reclaim project. The Reclaim project stands for Remanufacturing and Refurbishment Large Industrial Equipment. Reclaim is an Horizon founded project, an Horizon 2020 project. It started in October 2019 and it will end in September 2023. The main goals of this project are basically three main goals. Of course, these are promoting new technologies in order to reuse large machinery, recombine obsolete components, and implement predictive maintenance, adopting a circular economic approach. Another objective is reducing the aging of the machinery by improving productivity, and also define a decision-making procedure for the reuse and remanufacturing of robotic and electromechanical systems to be validated in 5 European industrial demonstration cases. The project has 22 partners from university, industries, technology providers, and non-profit organizations. As I said before, we have also 5 demonstration cases on friction weldings, white goods, shoemaking, textile, and wood manufacturing, locating in Germany, from Außerwende, from Gorenje, this is in Slovenia and Czech Republic, Podium, and Fulcius in Spain. About the standardization activity, that's the main point. I just give you what I've done during these years and what we are going to do in the next year of the project. So as Philip said in the beginning of this workshop, we're starting from the mapping of the existing standards. How we do this action, starting from identify the areas of the project. And of course, by starting from the area, we search the relevant standards and the relevant technical bodies and technical committees. So once we have this list, we have a reclassification from the areas, and then we check all the works with the partners in order to validate what we have done, what we did. The result of this first standards mapping is an online tool that we developed and we call the Standardization Toolkit. This toolkit you can see better if you go on the Reclaim website. It is freely available and gives you an estimation, a list of the standards, existing standards related to remanufacturing and refurbishment. It is divided by key area, keywords, and technical committee, so you can have an easily research of the standards that basically is not so easy when you go to a standardization body website or national one or also the ISO, because the library is very huge with more than 20,000 standards, for example, in UNI. So you can use these just to find what you are looking for in the maintenance and remanufacturing areas. We also realized a document, a paper document, a PDF document. It's a sort of a deliverable. It's not an official one, but that explains the content of the toolkit and give also some inputs about the standardization world. Also, we had a liaison agreement. We had this agreement with the most important technical committee at European level dealing with the remanufacturing and maintenance. That, of course, is the CEN/TC 319 on maintenance. We had this agreement, this special agreement, because for two main reasons. One is to have a sort of connection with the project results and technical committee. So in order to be aware of the standardization world of what we have done and what we are going to do in the Reclaim project, and also to able the experts of the Reclaim, the partners, to participate in first person to the standardization activity of the CEN/TC 319. And this is a practical way to transfer the results to the standardization world. Another practical way to transfer the result of research and innovation project to the market, it's a particular instrument of the standardization that is a press standard that Philip explained before, is the CWA. We are working on the CWA in Reclaim. We are on the project plan proposal. That means that we have to present it to the CEN, and if CEN accept our project plan, we can start with the technical work. We can form the working group and then start working on the CWA. So the main goals of this document is to develop a technical pre-standardization document that can transfer the result of research conducted in Reclaim, and that can be used by the market as a sort of guideline. What are the benefits for the companies? The benefits and the companies that are involved in Reclaim have a sort of competitive advantage to directly contribute to the development of this document, which will be available on the market and also will mirroring the market needs, of course, supporting the interest of the companies. So we have also drafted a title of the CWA. It's what you read on the slides: methodology for managing the maintenance of the large industrial equipment approaching the end of its design life. It reflects the Reclaim visions, the project visions. And once we have one, we will start. I said before that we are on the proposal submission. That this means that we have to give our project plan to the CEN for their approval. And we think that if CEN give us the okay, we can start the work, the practical work in the autumn. So at the end of October, beginning of November. So once we will start this work, the news, everybody can join the working group. Everybody that are interested in works on the content of this document, because as I said before, it's a practical way to transfer the results to the market, because the CWA It's a sort of document that codify an innovation. This kind of innovation should be tested then by the market in order to become a proper state of the art, and so a proper standard. After, as always Philip said before, a maximum of 6 years of duration. So that means that this kind of work will last beyond the project's lifetime. So it's something that goes beyond the project and will rest. And everybody can join this kind of work. So I think I'm finished. I've been quite fast, and thank you.
Thank you very much, Adriano. Could you please stop sharing your screen?
Yeah, I try.
Thank you very much. Now we have as a further panelist Andreas, a project manager of the Austrian standardization body. He is going to showcase Level Up, a project about protocols and strategies for extending the useful life of major capital investments in large industrial equipment. So very close to the Reclaim project. Please, Andrea, thank you very much. The stage is yours. Andreas, you're muted.
Can you hear me?
Yeah, no, yes. Thank you.
Okay, thank you very much. Fine. Can you also see my screen?
Yeah, perfectly.
Okay, thanks. So, hello everybody and welcome. My name is Andreas Ferkel from Austrian Standards International. Yeah, I'm working as a committee manager, and yeah, I'm also responsible here at the company for the Level Up project. The project is called the Protocols and Strategies for Extending the Useful Life of Major Capital Investment in Large Industrial Equipment. So the first slide, the goals of the Level Up project. These are very simple. This is to offer a scalable platform which is covering the all-over life cycle of such a machine, and the ranging is from the digital twin setup to the modernization actions, the diagnose and the predict of the operation of the physically assessed, and also the refurbishment and remanufacturing activities. These innovations will be developed to contribute to the following specific technical objectives. This is the knowledge management or the digital twins, the end-of-life strategies, and the inspections and entities. This was done in the Level Up project by inventing or designing 10 different special protocols which will describe what actions should be executed on the physical world. These protocols are the modernize, functional diagnostics, inspections, refurbishment, disassembly, upgrade, repair, remanufacturing, recycling, and reassembly or testing. And now to our task from Austrian Standards in the Level Up project. Our task was to create an overview about the existing standardization landscape. This was done by sending out a survey to the consortium of the Level Up about the regulations and standards which are used and triggered in the project. And the outcome will be, so the development will be a deliverable, which includes the overview of the standards which are affecting the Level Up project, and also a report on the standards which are used and triggered in the project, and a gap analysis between the existing standards and the needed requirements. So the task in the project from Austrian Standards. As a previous result, I can tell you that we haven't identified any barriers in the work of the project for the standards, and also the exploitation of the result by the development of a possible TENELEC workshop agreement. Now, a few words to the TENELEC workshop agreement for circularity protocols for extending the useful life of large industrial equipment. For this CBA, I will be the secretariat. So as you can see in the end, if you have any questions, please get in contact with me. So the CBA was initialized by according to the grant agreement of the Level Up project, and the scope will be the planned workshop specifies a set of protocols to ensure and standardize and formalize selection of processes for modernizing, refurbishment, repair, manufacturing, and upgrading of large industrial equipment. As you can see, it's a bit familiar to the Reclaim project. Principle and overlap between the scope of different Senelec TCs and the scope of the CVR hasn't been finally clarified. So there will be a decision until the beginning of August. The planned development time is about 50 months. Yeah, and as I said yet, if you would like to actively participate, please get in contact with me. So this will be possible. Thank you very much.
Thank you very much, Andreas, also for being so short in showing all the main points of your project. Thank you. Now, in your points. Now, really, last but not least, we have Marco Duarte from ZetaBreak. This project has finished, so you can have a complete overview of which have been the activities run during the entire project and which have been the main outcomes from the project, also from a standardization point of view. Marco, the stage is yours. Thank you very much. You're muted?
You.
Okay, perfect.
Yeah, can you hear me? Can you
perfect.
see the screen correctly? Okay.
Wonderful.
Thank you very much, Christina. Very nice to meet you here discussing the standardization topic. As Christina mentioned, so I'll be presenting ZetaBreak results, the project that is already finished last year. And starting with my presentation. So my name is Marco Duarte. I work at Innova. We are a consultancy company specialized in supporting the growth through innovation, international cooperation, digital transformation, and access to funding. So let me, okay. So ZetaBreak is a novel predictive maintenance platform to eliminate the unexpected breakdowns and extend the life of production systems. ZetaBreak was composed by a group of technical and business-oriented partners to deliver the innovative results in the predictive maintenance applied in factories of the future. The role of Innova in this project, besides the technical part and exploitation strategy manager, we were the leaders of the standardization activities. ZetaBreak solution comprises the introduction of 8 scalable strategies at component, machine, and system level, targeting the prediction occurrence of failure, as ZPredict, the detection of current emergency failure with Z-diagnose, the prevention of failure occurrence, building up, or even propagation in the production system with ZPrevent, the estimation of the remaining useful life of assets with ZEstimate, the management of the aforementioned strategies through event modeling, KPI monitoring, and real-time decision support in ZManage, the replacement, the reconfiguration, reuse, retirement, and recycling of components assets with ZRemediate, synchronizing remedy actions, production planning, and logistics with ZSynchronize, and finally, the preserving the safety, health, and comfort of the workers with the ZSafety. So the cluster works together to assess the standardization opportunities and share knowledge best practices. Standardization elements evaluated included interfaces, communication protocols, quality inspection, management systems, performance monitoring, key risks indicators for manufacturing, and others as well. So the ForeSee supports new regulation and standards to accelerate the adoption of the new manufacturing systems and aim for the easy market acceptance for our solutions. So this was the mapping that we had back in 2018, where we started with a joint vision of the ForeSee projects at the time. We analyzed the needs from the industrial use cases and market assessments, and also then followed with the analysis and evaluation of the standards. And from 2020 until now, we've been communicating and creating awareness regarding the standardization adoption and also the benefits which standardization can bring into the projects and also then applied in the industry. So the Innova team was the leader for the standardization activities in that product, in that break, but we also coordinated the standardization activities within the ForeSee clusters at that time. So in a parallel way from that break, in line with other projects, we started with a market evaluation and identification of the standards. Proceeded with the assessments from the technical partners contributing to the knowledge and experience that could offer by the standardization, the reassessment and validation, as long as the technical activities in the projects were progressing. It is important to make this reassessment and follow up with evaluation on the importance of the standards, and then building the radar charts to represent the adoption level of the standards, both in data related and also in maintenance related standards. Finally, the collaboration to represent a common vision for the ForeSee cluster on the standardization was performed. So starting with the first analysis on the importance of the standards. In that break, we evaluate the standards importance by categories on the left, and by the technical components in the project represented in the right chart. So the interoperability followed closely by the security and communication categories is the most relevant category in that break. In fact, interoperability becomes a key aspect in that break for automatic production lines. Following the architecture that break, the data is captured on Orion for the respective maintenance analysis, and then it's converted in NGSI. This is an example of the benefit of the standardization that I will explain later. On the other hand, the adoption of standards in the DSS and failure modes, as well as defected analysis models, assume higher importance. The figure represented on the right side. This analysis could be helpful to determine the potential gaps in the standardization across that break architecture in the upcoming projects. So the radar chart, which was already introduced by Yves related to the uptime project, we had this tool as it was selected to better perform the identification and continuous monitoring of the standards application. The radar chart is a graphical representation of the relevant standards on the global radar screen, plus a description of each standard on a separated table that I can provide it to you later. The radar chart provides a simple view then on the standardization assessment, illustrating technology, all the elements that they may be relevant to the project developments, as well highlighting the candidature standards for adoption and those standards that have been adopted as part of the joint effort. So the chart is divided into 4 quadrants, showing the ForeSee strategy for delivering the candidature standards, adopting, monitoring, or participating in the development, or in the ecosystem development of standards. So each standard on the radar chart is used to provide the visibility of the status and maturity of a standard or initiative. Each standard or initiative are first identified and further continuously updated to track the progress on the standard or initiative that evolves. This continuous process of monitoring a standard or initiative includes the current action level, and the quadrant and a link for the full descriptions must be provided. So we had the 2 exercises in the ForeSee cluster at that time in 2021 when we presented the results, where it was included besides that break, the programs, Prophecy, Precom, Serena, and Uptime projects. And by that time we had performed the 2 exercises. So the radar chart with data related standards that you are seeing now on the screen, and also with the standards specifically related to maintenance. So regarding the data-related standards, these standards were classified in the transverse standards, domain discipline standards, and technology standards, which is also parallel to the other analysis. But in this chart, one thing that we can observe is that the standards to support the data access, treatment, and transfer are the most important, such HTTP, JSON, RDF, NGSI, or KIF standards. However, not only technological and domain standards live in this ecosystem. Ontology, which is a broader area, assumes the importance on management risks, requirements engineering, and system engineering processes. Regarding the second exercise with the predictive maintenance standards, this chart displays the most relevant and is applied in the ForeSee Cluster projects. So the radar chart on maintenance-related standards highlights the failure modes and effects analysis, FMEA and FMECA, methodologies together with Mimosa, demonstrating that these two standards are adopted and commonly used within the ForeSee Cluster projects. Moreover, the focus was given to the maintenance indicators and dependability management standards as for monitoring external developments. To conclude, the maintenance task scheduling and predictive maintenance ontology standards have been already identified and are considered as candidates to be adopted for the predictive maintenance roadmap due to their relevance, knowing how to describe the chronicle concepts and their relationships. So moving on to the one use case examples in the ForeSee cluster, picking from one use case in that break, which was the Philips use case. It was the predictive and with the predictive analysis on the blade machine. The machine production is often interrupted because of the shaving cutter forming press stops. So the press has 6 dies which operate a cutting or a blending process. So these processes were monitored by acoustic emission sensors. 2 critical failure modes within dies were analyzed, and based on the number of punches per second, the acoustic emission was analyzed with the quality predictive monitoring assessments. So the MQTT provides all the data by topic. The interface enables the runtime getting all the data from MQTT and save all the data into files into acoustic emissions. Then the exchange of information occurs in IDS connector, get a convert NGS format for the data subject to be monitored and to be sent into Orion context broker. And finally, all the data entities can be consumed by the existing consumers. So the objective is to assess through alerts into usage of the cycle as expected. The acoustic emissions determine whether there is a wear or there are anomalies through machine learning. So how we standardize the data structure. In this example, NGSI format is used for any type of software, a large amount of information to make available for customers. And the use of these standards facilitates the customers, as many of them do not have the technical knowledge or are not prepared to consume the information as it is collected. Then the break, in particularly within this use case, allows always to be available in the same format and can be consumed through any type of software. So regarding the benefits, the NGSI then offers a set of business benefits to ZBreak. So the platform is widely used as ZBreak benefits from the being fed by a large number of customers. The data analysis process is easier as the customers and technical providers will request the data in the same format. The data structure can be easily replicable through different customers, as ZBreak does not have to make a new structure for each customers. And finally, the platform is prepared to bespoke developments as customers can filter according to what are their needs in terms of data. So NGSI was selected upon the cost-benefit analysis, as many other standards could be suitable candidates. So to conclude, while ZBreak succeeded in developing and demonstrating the viability of comprehensive framework to build around each industrial case, it has been identified key future steps for the product roadmap that are required to address the standardization challenges from the market and to industry needs. And I will name the most important ones, which are the handling of the data that is generated in the planning processes and product development towards a common ground for reliable and trustful data exchange across complex networks, improving data exchange models and standards along with tailored product models to a particular use case, and finally performing risk evaluation on machinery through automated process to provide a complete system that minimizes the risks indicators and the availability of quality of the machines. These challenges become more relevant when looking at the collaboration made in ForeSee Cluster, which tentatively represents boosting of European leadership in this domain. Therefore, the future work regarding standardization will naturally seek collaboration with formal committees and working groups by liaison members of the consortia. Such achievement will promote homogenization and consolidation of the technology trends towards an effective market of platforms for predictive maintenance and boost the EU position in the global market. So I left here my comments if you would like to have any clarification or if you wish to contact me in the future. Thank you very much.
Thank you very much, Marco. Thank you for all your presentations of all the panelists. I think it has been really a broad overview of all your experiences. Just to sum up all your projects showcasing, we can say we have seen how standards have been considered in different ways in different European projects in a more structured, like with dedicated activities and sometimes also tasks and work packages, to sometimes how standards have not been considered from the very beginning of the proposal writing, but then they have come up during the project and during their activities as something which was needed both from the beginning as a mean of exploring the state of the art and avoiding reinventing the wheel in the activities, and later on for the outcome to understand that to let this innovation coming up from research projects to be accepted from the market and be interoperable with the other existing systems, it is important to have a standardized approach. I think this is the main message I could give as a conclusion of this webinar. Just before saying goodbye to everybody, I would just kindly ask you to give us your very last impression about how standardization can boost innovation after all the presentation you have seen. So I hope you can see my screen. There is another very fast poll. You will have just 2 questions, and we will ask you again, how do you think that standardization can boost innovation? You can access it. Maybe the easiest way is through this QR code. Otherwise, it should have been sent in the chat again, the link. But I know that during the first poll, there were some troubles with the questions. So if they still have problem, please use the QR code. I will stick on this slide and give you just a minute to answer, and we will see your answers, and then we will close the webinar. Thank you very much. Yes, you should see the link now. I hope this webinar was useful for you. If you had not had experience with standards and research and innovation projects, also to have some hints on which can be the activities run within the projects and how you can also do your activities differently. Even if you have not still considered the standards as one of possible tool to help you in a tool of your toolkit to support you in the activities of your research projects. Okay, I would just let you see the answers. Okay, just live, just a second. Okay, you can see we have Alf and Alf. And how do you expect that standardization can support innovation? We can see that there are some questions. And again, the point of making the innovation going to the market comes again. Giving access to cutting edge technologies in a simple way, it could be done by a better interconnection between the different stakeholders. This is also an important point because we have seen how standardization can help you in network with relevant stakeholders. And IC can be also a guide for making innovation ready to be exploited. So again, the point of making innovation something more closer to the market and accepted by the market is something that seems quite accepted by people answering to these questions. We will gather all your questions and we will make a kind of sum up with all your contributions, and this will be included in the in a roadmap which is going to be developed within ForeSee Cluster to give a guideline for predictive maintenance to the companies. So in this roadmap, we will include a standardization chapter where we will also wrap up all this information and all hints collected during this webinar. So thank you very much for all your contributions and for all for your participation. We will share with you all the slides presented today, and the recording of this webinar will be made available on the YouTube channel of UNI website. We will share with you all the information. If you have any question, I'm sorry, there is no further time now, but I will send you an email with the email address where you can send us the questions. We will be eager to answer all of you. Thank you very much. Thank you all the panelists for their participation, really much appreciated from us, and to all the participants for being with us for this afternoon of July. See you soon, hope.
Thank you very much.
you.
Thank you. Bye-bye.
Bye-bye.
Thank you. Bye.